Hi guys, welcome to JIK 224 E-Kuliah series. I'm Dr. Sumia Sabah and this is the 8th video covering chapter 2, which is mesocompounds. In the previous video, we have looked at what is enantiomer and what is diastereomers. A mesocompound is another type of stereoisomers. So we will discuss more details on mesocompound and how to identify them. Upon completion of this topic, you should be able to identify mesocompound. So what is mesocompound? A mesocompound is an archival compound that contains two or more chirality centers. So they are actually a chiral compound. Mesocompounds generally contains a plane of symmetry so that they can possess two identical halves. So there's the two characteristics of a mesocompound. They are archival, which means that they can have two or more chirality centers and they must have a plane of symmetry. For example, here we have a compound here. So when we put a mirror in the middle of the compound, we can see that we can divide these two compounds into two and they have identical half. So this is a mesocompound. So compound C, which is 2,3-dibromobutane, contains a plane of symmetry and is archival. Why they are archival? Because one of its stereoisomer is superimposable on its mirror image. So let's look at more examples. So this is the 2,3-dibromobutane. We can draw all the possible stereoisomers. They have two chirality centers. So based on the equation 2 to the power of n, so we have two chirality centers, which means that we should get total of 4 possible stereoisomers. First, let's draw A and B. A and B is actually a pair of enantiomer. Why? Because they have a non-superimposable mirror image of each other. So there are two more possible stereoisomers. So we could have C and D. But when we draw C and D, we can see that actually C and D is identical to each other. So there are only 3 possible stereoisomers because C and D are identical. And when you look closer at compound C here, you can see that actually when you place a plane of symmetry at the middle of this compound, they have identical half. So they are actually a mesocompound. On the other hand, A and B are diastereomers of C. So for diastereomers, they should have non-superimposable, non-mirror image. You can see here that A have one of its configuration here at your right is similar to C, while B have a similar one part of a similar configuration at your left. So they are actually a pair of diastereomers. There are only 3 stereoisomers and not 4. Why? Because C and D is identical. Let's look at another example. This time we have 1,2-cyclopentane-diol. This is actually alcohol solution, so we could draw them as cis and trans isomers. In cis isomer here, we have both of the hydroxyl group facing upwards, while for the trans we have one hydroxyl upwards and one downwards. From this here, you can see that the cis isomers are actually identical, and we could also place a plane of symmetry in the middle of the compound, so we could have two identical halves. The cis isomers are actually a mesocompound, while for the trans isomer there are a pairs of enantiomer. And from here we could have pairs of diastereomers, meaning that one of the enantiomer here is a pair of diastereomers to the cis isomers. And this compound also could have a pairs of diastereomers with the cis isomers. From this compound here listed from A, B, C and D, identify mesocompound. So the first thing that you can do is that search for the plane of symmetry. From here you can see that compound A and D has a plane of symmetry. They can have two identical halves. So A and D are mesocompounds. Let's look at example number 2. Which of the following are mesocompound? For A here, they are not a mesocompound because they do not have plane of symmetry. While for B here, we could actually draw a plane of symmetry in the middle of the compound. So, it is a mesocompound. While for C here, it's not a mesocompound because it does not have a plane of symmetry. For example number 3, determine which of the following compounds are chiral. Star any asymmetric carbon atoms or chiral carbon and draw in any mirror planes. Label any mesocompound. So we have here 3 compounds. You have to identify the chiral carbon and also determine whether the compound is a meso or not. For compound A, we can draw its mirror images and we can see that there is actually 2 chiral carbon. So this compound does not have a plane of symmetry and it has non-superimposable mirror image. Hence, it is an enantiomer of a chiral compound. For B, you can see that we could have an internal plane of symmetry. This compound has mirror planes of symmetry and are achiral. Because it has asymmetric carbon atoms yet are achiral, it is a mesocompound. But for C, we could draw its mirror image and drawing this compound in its most symmetric conformation, which is flat, shows that it does not have a mirror plane of symmetry. When we draw its mirror image, it is found to have an enantiomer. So these 2 compounds is a pair of enantiomer. So as a summary, a mesocompound is an achiral compound that contains 2 or more chirality center. Most mesocompounds have a plane of symmetry. This is the reference, and if you have any question, feel free to contact me at my email address. And thank you for listening.